So in this video we are going to solve one problem based on what DC-DC converter drive for the rheostatic braking. Okay, so we have solved the three control methods, which is first one was power control or acceleration control, second one is regenerative braking. Now we have come for the third one, which is the rheostatic braking. Okay, so the DC-DC converter is being used in rheostatic braking of a DC separately excited motor. Here it is DC separately excited motor. The armature resistance is given. So this is the given value. Let us just mark it. So this part is given. Braking resistance RB, because rheostatic braking you are introducing one braking resistance RB, right? That is the important fact here. And the back EMF is given as kV is equal to this thing. Back EMF constant. Okay, the motor voltage constant. And the armature voltage. Okay, IA is also given 150 amperes. Then what else is given? The field current is also given IA. The duty cycle of the DC-DC converter, that is 40%, you have to consider K value as 0.5. So I'll just write what all the things given. So in the first part of the question we have to calculate what? A part is given, the average voltage across the DC-DC converter VCH we need to calculate. Okay. So remember in the rheostatic braking that VCH will be same as what VB, where VB is nothing but the average voltage across the braking resistor, and it is given by RB into IA into 1 minus K. Now this IA into 1 minus K is nothing but IB itself. Now IB is nothing but the average current of braking resistor. Now IB also is not given in the problem, IA is given, so we will go with IA itself. Now RB they have given it as 5 ohm, so 5 into IA value is 150 into 1 minus K, K is 40%, that means 0.5, 40 by 100 is how much? 0.5. So when you calculate this, you will be getting it as VCH is equal to 450 volts. So this is nothing but the average voltage across the DC-DC converter VCH. Okay, then let us go for the second part of the question, which is to find out what the power dissipated in the braking resistor PB. What is the power dissipated by the braking resistor PB? That also we are having direct formula. PB is equal to IA square RB into 1 minus K. Okay, so IA is given 150, so 150 square you have to take into RA value also is given 0.05 into 1 minus 0.4. Getting the PB value as how much? 67,500 or 67.5 kilowatts. Okay, this is the answer for PB. Second part of the question also done. Third part of the question, if you see, it is the equivalent load resistance of the motor acting as generated. R equivalent we have to find. This is for the rheostatic braking, you have to remember that. So C part will go for C part. R equivalent, what is the formula given over here? RB into 1 minus K plus RM. To write the RM value, it depends on the motor. For DC separately excited motor, it is nothing but RA plus any other series resistance. So RA only is given, so we have to take RA. What is equal to RB value is 5 ohms into 1 minus 0.4 plus RM is same as RA 0.05. You will be getting it as 3.05 ohms. Or you can apply one more formula, R equivalent, which is the direct formula, which is given by VB divided by IA. Okay, so VB is nothing but how much? We calculated here. VCH is same as VB, 450 divided by IA is 150. So you will be getting it as 3. So approximately we can say it is almost same, 3.05 ohms and 3. Okay. Next, C part is done. So either you can say use this formula or this formula, anything is fine. D part, the motor speed they are asking. So in order to find out motor speed, you have to relate it to the back EMF. Okay, generated EMF you have to relate. EG is equal to kV into omega into IF. From this you can get omega value, which is equal to EG divided by kV into IF. Now EG value is not given, IF is given and kV is given, right? So IF is given and kV is given. We need to find the EG value. So what is the formula of EG? We have studied. We have to relate it with VA. This is the DC separately excited motor. So Eg becomes what? Vb plus Ia into Rm. Rm is basically Ra for DC separately excited motor. Vb is equal to what? 450 plus Ia value is how much? 150 into Ra value is 0.05, 457.5 volts. Substitute back in this. So omega becomes Eg divided by kV into If. So Eg value is 457.5, kV value is 1.527, If is 1.5. So we will be getting 199.7 radian per second. In order to convert it into what? RPM, multiply with what? 30 by pi. Omega becomes 1907.4 RPM. Now we'll go for the E part. The peak DC-DC converter voltage V peak. Direct formula is there for the peak value, that is given by E part. V peak is equal to Ia into RB. V is equal to IR, same formula. 150 into RB, the braking resistor 5